All right, so we talked about some of the control mechanisms a little bit. And there's also some renal autoregulation, which means what, do you think? Regulates itself, so it means there's no hormones coming from somewhere else or the brain's not involved. It's just the kidney does it by itself. And the first one is the myogenic mechanism. And for that one, smooth muscle cells in the afferent. So they constrict or contract when the blood pressure is elevated. So in your group there, why is that a good thing? Why would you want to do that? Maybe think about what would happen if it didn't do that.
I don't know, I wasn't here. That's what happens in the heart. You know what I mean?
So this only happens to the kidney. This is not a body-wide response. So if you have high blood pressure in the afferent, those muscle cells contract. Why would they do that? Continue to discuss. Remember the afferent's going in to the corpuscle. Maybe glance back at your pictures or something. All right, so let's take this a couple steps at a time. Let's say this mechanism wasn't there. What would happen to the filtration rate if the blood pressure is high?
Wouldn't it increase?
It's going to increase, and it wouldn't absorb enough, right? Because the higher blood pressure, that makes more filtrate, faster rate, not reabsorbing things enough. So how would this fix the problem?
Slow it down so it could.
Exactly, just like you wrote on these, constricted afferent means you're reducing the amount of blood coming in to the corpuscle, so you're going to filter things at a more normal rate. That kind of makes sense. If you've got too much coming in, which is basically too high of a blood pressure, just slow it down. So have those muscles contract. Make the hose smaller. So because thinking back to here, if you have a constricted afferent arteriole, what does that do to the hydrostatic pressure in the capillaries, in the glomerulus? It lowers it. Because you're putting less blood into it. So it'd be less pressure. So I would certainly say on your test or something, probably the first thing I would do for this chapter is draw myself a little picture and just put the afferent, put the corpuscle, whatever, and then put the afferent here, just so you can think about, is there more blood coming in? Is there less blood coming in? More leaving, less leaving? Because I think that's pretty easy to see the pressures if you have a picture to look at. Because then it's obvious, like, oh, if I squeeze this one, there's less blood coming in. If I squeeze this one, more blood stays in here, so the pressure's higher. Does that make it easier if you have a picture? So you're going to draw a picture like that on your test? Because it's harder if you just try to see this in your head and think about changing the size of it all at the same time. It gets confusing, right? So it's a really helpful thing. Put down what you know first. All right, so that's the simple one. But we also have a more complicated one. Tubuloglomerular, it even has a longer name. So just from its name, what two parts of the kidney are involved, do you think? The tubule and the glomerulus. And basically we've got something in the tubule that can see how fast the fluid's going past it. So it's like kind of a direct measure of the filtration rate. And that's the macula densa cells. So they're activated So they're like the receptor. And they tell the juxtaglomerular apparatus, we just call it the JGA, and that tells them to stop making nitric oxide. And this one's confusing because it's like a double negative basically. So nitric oxide, when it's there, so if we have a whole lot of filtrate coming in, maculodensis cells tell the JGA to stop making nitrous oxide. If there's normal GFR or low, these cells are not activated, and the JGA is making nitrous oxide, which is telling the afferent arterioles to dilate. Because these cells are not being activated, so we've just got a JGA making nitrous oxide, causing dilation of the afferent. But when it's high, these maculodensis cells are basically turning off the JGA cells. So everything below it, like this and this, is that going to happen? No. It's not. So instead, they're going to constrict. And if they constrict, what happens to the filtration rate? So we're constricting the blood coming in just like in the first one. So slower GFR. So normal state, making nitric oxide, dilating the afferent. When there's high GFR, you stop making nitrous oxide, and the afferents constrict instead. This one's a little confusing. So I guess we have this in two places, because I put it back on this other assignment. But it would make sense. It doesn't matter. Same question, but here it is on the actual worksheet for today. So go ahead and think about this one just on your own for a little bit. See if you can't write something down, even if you're not really sure. All right, so talk that over with your group and make sure it's kind of fully explained. So make sure you've got a filtration rate goes up, goes down, stays the same in your answer somewhere. All right, so who thinks they have an awesome, perfect answer for the first one? So if the filtration rate was too high, you wouldn't fix it. So GFR would stay high if it was high, or stay normal if it was normal. It depends on what situation you're in. Because if you had a normal GFR, this is how you're supposed to be, right? In a normal GFR, are these cells sending a signal at all? They're not, right? So A is only a problem if the filtration rate is too high. Now you can't fix it. Because this is what you're supposed to do, but this step here is broken. Yeah. So now we have a high GFR, but we're sticking with dilated arterioles. Yes. You'd start losing stuff, ions, and maybe glucose even. I didn't make a quiz for today. Too lazy. Oh, I should give these back. That's good. So we have plenty of time to do the hormonies. Or that's how my grandma called them. She's like, my hormonies are acting up. All right, so probably you could see so far having all of this perfectly regulated is super important. so that you make the right amount of waste, you reabsorb the things you need to, and also helps your blood pressure stay at the right level. So there's a whole bunch of hormones involved too. I just picked out 3 of them. And so this means you've got signals from other parts of the body telling the kidneys to change what they're doing. And the first one is ADH. We talked about this one already a little bit.
Yeah.
When did we talk about it?
Cardiovascular.
Oh, right. Yeah, for blood pressure. So you should know something about it, but we're going to talk a little more in detail about what it does to the kidney. Because all we really said was, right, it increases blood volume. So we're going to see how that works. But maybe you remember the stimulus was low blood pressure or low blood volume. Do you remember what organ makes ADH? What gland? That would be, kind of makes sense, but no. You may know. It is the pituitary gland. Where's your pituitary gland? It's like hanging out of your brain up here, below the hypothalamus. So way up here in your brain, you say, hey, my blood pressure, blood volume's getting low. Make a hormone. It's going to try to fix that problem. And one thing it does is make you thirsty. But what it does in the kidneys is it causes an insertion of this protein called aquaporin. What do you think aquaporin does? Well, the first part of it, water, what do you think porin means? A pore, a hole. So you put this protein into the collecting tubule, which lets water be reabsorbed more easily. So if you've got, because water can get reabsorbed, but it's not always super efficient. So we've got normal, a normal collecting tubule, or no ADH around. A lot of the water stays in the tube and doesn't come into the blood over here. When there's ADH, you're going to put special little pores that are called aquaporins, and they're going to let the water through. So it can leave the tubule and come over here to the blood. So it's going to come into the blood more. More water is reabsorbed back into the blood when ADH is around, which is good because if you put more water in your blood, what happens to your blood pressure? It lowers? Goes higher because now there's more blood, which increases the pressure. So you've got more volume in the same amount of space.
Would that be bad for people with high blood pressure?
It would. So would you make ADH if you had high blood pressure?
No.
You wouldn't. But you're right, if you did make it, that would make it worse. If you're making ADH, are you making more urine or less urine in the day? It's less, right? Is it going to be more yellow or more clear?
More yellow.
It's going to be more yellow. Exactly. So every time you go to the bathroom, I want to know, you better be thinking about your ADH levels. It's your homework for this week. Just take a little pee, look in there, and be like, ADH, no ADH. It's your assignment. Honestly, I actually do that. Like, you may think I'm crazy, but any ADH questions? We're going to talk about it more later, too. All right. There's also a complex system that we're not really going to get into. Renin, aldosterone, angiotensin. If you've seen like the diagram of it, you probably don't want to know all about it. But for this chapter, we want to know what these hormones do to the kidney. It's all going back to the nephron, right, and the filtration rate. So very similar stimulus to ADH, right? Low blood pressure, dehydration, which causes low blood pressure. And these hormones are produced. Renin's actually made by the kidney. Angiotensin comes along later. But what they do is they cause vasoconstriction of afferent. If you constrict the afferent, right, what are you going to do to your filtration rate? Decrease it? Are you going to reabsorb more water and solutes or less? So confusing. So if your filtration rate slows down, you reabsorb almost everything. If you reabsorb more water, what does that do to your blood pressure? Brings it back up. So it's one function. Another way it fixes the blood pressure is it actually directly affects the tubule and causes it to reabsorb more sodium and chloride. And because of osmosis, it brings water with it. So we change the filtration rate, slow it down, and separately increase reabsorption of solutes in the tubule. So both those things help fix your blood pressure. All right, and as you learned in 21, ANP is your high blood pressure hormone. So if there's high blood pressure in the atria, which is in the heart, the atria makes ANP, and it's going to help lower your blood pressure by doing all these things. So if you dilate the afferent, that increases GFR, because now you got more blood coming in, and you constrict the efferent at the same time. So that keeps more of the blood in the capillary. So once again, increasing the pressure and the GFR. And if you have more filtrate, are you going to absorb more or less? You're absorbing less. So you're leaving more ions and more water in the urine, basically. Which means, what's going to happen to your blood pressure? Decrease. And so you could say, like, next time you're going to the bathroom, you're like, I'm lowering my blood pressure by a little bit. There's lots of fun stuff you can think about in the bathroom. All about your kidneys. I'm serious. Y'all are going to be thinking about it now. Which is one reason. If you go exercise a whole bunch, do you usually have to go to the bathroom?
Yeah.
Why do you think that would be? You go exercise for like half an hour and like almost always like, God, I have to go to the bathroom now. Yeah. Blood pressure went up, so maybe you made some ANP and did all this. You're going to be thirstier, but even if you don't drink anything while you're exercising, it's like right away, God, I got to go to the bathroom now.
Yeah. I always got it. You better go to the bathroom or you're going to stop. Yeah.
All right. So what does ANP do to glomerular filtration rate? Quick quiz. I don't think it's open or on. Hold on. So you're right. It does increase GFR. That's how you get rid of your extra blood pressure. All right. Is that enough to fix high blood pressure, though? Like if you're eating tons of salt or you just have some genetic thing? Obviously, it's not enough to lower it all the way back to normal. Otherwise, no one would have high blood pressure. But lots of people do. All right. What about this one? Glomerular filtration rate is increased by all of the following except. So probably what you want to do is think about each one of those statements and say, is that going to increase or decrease it? And then try to answer it after that. All right, so go ahead and chat with your group then about each of those. Maybe just take one at a time. Say A, did you say increase or decrease? B, increase or decrease? All right, so what do y'all think for A? It does decrease GFR, right? So we have these slides back here. Vasoconstriction of efferent, which is going to decrease the GFR. What about B? What does A and P do? It increases it. What about C? Relax the afferent. Does that mean constrict or dilate? Doesn't mean dilate. So if we dilate the afferent, it's going to increase the GFR. And for D, it's going to decrease it. So it is E. So then it is increased in all the following except, so then the answer is A and D. And honestly, that's a hard question. I mean, there's a lot to think about. A lot of little steps to go through. Like I had to sit down and think through each of the steps to figure it out, and I wrote it. It's still not easy. It's not like I just look at it, I'm like, oh, it's A and D. To like kind of think it through, like, what does those hormones do? Or one thing that can really help is if you just say A and P is from high blood pressure, all those other hormones are from low blood pressure. And then from that, you could probably sort of figure out, well, if we have high blood pressure, do we want to increase GFR or decrease it? If you have high blood pressure. Do you want to increase your filtration rate or decrease it? Increase it, because then you reabsorb less. So immediately you would know, oh, A and P must do something to increase GFR. And the other hormones must do things to decrease it. So you can boost the blood pressure. So basically what we're doing there, that's O on, wait, that's the other study guide.
CD.
I don't know where it went. Doesn't it say something about like what exactly it does to the kidney, right?
The C is describe the stimulus that causes each of the following hormones.
Yeah, and then D.
Describe how each of the following hormones affect the immune system.
Right, so we're moving on from 21, where you just said, oh, it raises the blood pressure or lowers it, to now that you know how the kidneys work, what does it do to the kidney itself that changes things? What? Mm-hmm. So what did ADH do to the kidneys? Increase the absorption of water. And how did it do that?
Adding water to aquaporin.
It makes aquaporin go into the collecting tubule so the water can come back to the blood. That'd be the whole answer for that one. And it's all on the slides, basically. So, all right. We've got a few questions, a few more questions. What did I write on these? All right, so try 2 and 3 on your own again. So just looking for, you don't really need to explain it. You go to say increase or decrease for each of those hormones in those situations. All right, so question 2, down or decrease, increase, increase. So what y'all got? Question 3 is the opposite. Increase, decrease, decrease. All right. Which means, are you ever making like A&P and ADH at the same time,
Yeah.
right? Because they have opposite stimuluses, so it's either one or the other. Do you think you're usually making ADH and renin, angiotensin at the same time?
Yes.
Yeah.
Right, so they kind of go together. Which is crazy to think about if you've got, high blood pressure. That means you're making A&P, the myogenic mechanism's activated, the tubular mechanism activated, all at the same time to try to fix the GFR being too high. So you got lots of sort of backup systems involved. All right, so try number 4 then. We'll do this one maybe just as a group to start with. So what would happen to the person's nephrons if you make too much of each of those hormones?
Sorry.
Oh, that's question 4.
Referring to GFR rate.
Maybe even a little more specific than that. But you'll probably have GFR as part of your answer if it's affected. So you kind of think about what those hormones did, and what if it was too much of those hormones? What would happen? So whatever you're writing for filtration rate, you need to explain why it would change as well. So did you change the afferent arteriole? Did you change the hydrostatic pressure? What changed that? All right, so let's talk about a few things with those. First, one thing I noticed, increased GFR, more filtration rate. What does that do to your blood pressure? Why would it decrease it?
Less of reabsorption.
So GFR, it's like opposite of blood pressure. Like if you have if your GFR is high, your blood pressure drops. If you're decreasing your GFR, what just happens to your blood pressure? Goes up. Here's one. What about how often you're urinating? If you're increased GFR, you're going to urinate more or less?
More.
And this one. Because it's all based on how much you're reabsorbing. So if we wanted to add even another column, reabsorption. Wait, I want to put it here. Let's just say this is reabsorption. So if I don't have any room, I'm out of room. All right, reabsorption, increased GFR, reabsorption going up or down?
It's the same as blood pressure.
Yeah.
So
Because the more fluid you've got coming through, the less of it you can reabsorb. So you pee more out and you reabsorb less. You decrease GFR, your blood pressure gets increased because you're reabsorbing more and you're making less urine. All right, so then going over these, ADH. Okay, so increased aquaporins in the collecting tube, more water in the blood pressure go higher. Was there anything in here about changing the filtration rate for ADH? No. So ADH did not change the GFR, which I think almost everybody wrote something about GFR changing for ADH. So nowhere in there did we talk about constricting afferent, dilating efferent. All we changed was how much water you reabsorb directly. So ADH is kind of the different one. It's not changing anything at the glomerulus, any GFR. It's just bring in more water. And what's the next one? Angiotensin. What did that one do? Some other group.
It increases your blood pressure.
Angiotensin, it increases your blood pressure. Let's start at the beginning. Does angiotensin increase or decrease your GFR? It decreases it because what did it do?
It constricts the afferent arterial.
Right?
So it raised.
Yeah. Is that what you said?
Yeah.
See, even I get this stuff backwards. Yeah. So you're right.
Yeah, I was like,
Yeah, you're right. If you decrease your GFR, you reabsorb more and increase your blood pressure because you constricted. Wait, what did you say? Yeah, constricted the afferent.
Man, that's one of the changes in the e-current. Okay, no, I didn't fix that.
So you think that person, would they have, because since it says like excessive angiotensin, would they tend to have any blood pressure issues? They would just tend to have high blood pressure, right? Yeah. So you've heard of people having, high blood pressure in their family. Maybe it's one of these like too much angiotensin is produced, just from a genetic mutation or something. And what about A and P then?
Opposite.
So if you have too much A and P, are we in
Yes.
this one or this one?
The top one.
Right? Because A and P increases the filtration rate. How did it do that?
by
Dilating
Dilates the afferent.
efferent and constricting the efferent. So we're increased GFR, which lowers the reabsorption, lowers the blood pressure. And more P. Is this confusing enough yet? You're getting it though. Y'all have lots of good talking going on. And you got really close for most of those, or got them right. All right, 5 minutes. I'm going to skip that stuff because it's not actually on there. Just wanted to show you this one. Kind of an overview. So you've got your glomerulus up here, everything getting filtered out. And then everything in red, it's showing you which part of the collecting tubule you're reabsorbing those substances. So we're taking in water, potassium, sodium chloride, glucose, amino acids, more sodium chloride. So you can see all these different ions and stuff coming back in. And then way towards the end is where you actually do secretion. So if you need to get rid of urea, you need the hydrogen, like if your pH is too low or something. And then here's ADH. So ADH puts those aquaporins at the very, very end of the tubule. So after you get all these solutes out, if your blood pressure's low, ADH comes down here and tells these cells to make aquaporin to let the water back into the blood. And that's the key difference for diluted versus concentrated urine. No matter what's going on, as you bring in all those solutes, like the sodium, the glucose, the chlorine, you're bringing in water, which is obligatory. So anywhere you see these solutes coming in, water comes with it because of osmosis. You can't really change that. But what you can change is how much water is reabsorbed in that last little part. So they call that facultative. It's regulated by ADH, and it does that by making that aquaporin channel, a pore for water. And we've got the percentages up there. So 90% of the water is reabsorbed in that first part. 10% of it is by ADH. Because you remember, we filter, what was it, 180 liters of water every day? So you've got to automatically, obligatory reabsorption gets 90% of that. And then the other 10% you can leave in the urine or you could reabsorb it, depending on how much ADH you've got. I mean, if you keep chugging water, you would just keep, I mean, I feel like if you have coffee in the morning and then drink like 2 liters of water or something, I mean, how many times are you going to the bathroom? Like a lot, right? All right. So that means the concentration of your urine, when we say concentration, we mean like percentage of solutes over water, basically. So if you're drinking lots of water, you make diluted urine and lots of it. If you're dehydrated, you make concentrated urine of low volume. I think everyone already knows that. When would you be making ADH? First scenario or second?
Second.
Be second, right? Because you're dehydrated, you need to conserve your water. All right, so the first one is diluted urine. So this is no ADH. And all these numbers are on here are how concentrated the urine is. The bigger number, more solutes. And you can see it starts 300, 550, 900, and it starts to get more diluted because why does it get more diluted as you pass through here?
More of the solutes are coming down.
The solutes are getting reabsorbed and you're leaving behind a lot of the water. And finally at the end, now you're just down to 65. So pretty diluted. Not a lot of solutes in it. This would probably be pretty clear, basically. Now, if you make concentrated urine, everything's pretty similar as we go through, right? So it's like high, then it gets low again, but then as it comes into the collecting tubule, we're bringing in all this water, which is leaving behind lots of solutes, so the concentration of the urine is going up. So the difference is all, or at least mostly, at the end there. So now we've got concentrated, and they even made it more yellow for you in the diagram, which I just noticed that. 1,200